Hey everybody, welcome to this video on the availability heuristic and overconfidence. There's going to be two subjects to this video, as the title suggests. First, the availability heuristic, and then the bias of overconfidence. So first, the availability heuristic. So the availability heuristic belongs in this family of heuristics, or rules of thumb, that we use when coming up with judgments about probability. This family being derived from the work of Daniel Kahneman and Amos Tversky. So how does the availability heuristic work? Well, like we said, it's a rule of thumb for assigning probabilities. Agents employing the availability heuristic tend to judge the probability of an event according to how mentally available the event is. That is, how easily it can be brought to mind. Right? So something that comes to mind very easily will be assigned higher probability than something that you wouldn't think about as readily. So the general rule here is that X is more likely than Y if X comes to mind more easily than Y. Right? This is for those who employ the availability heuristic. So if we're to think of this in terms of arguments, right? We'd consider an argument from P to Q versus an argument from P to R. And we'd say that if P brings Q to mind more readily than it brings R to mind, then we might judge the first argument more plausible than the second argument. So for example, if P is the proposition that I went to Pizza Hut, and Q is the proposition that I had pizza, and R is the proposition that I had a hamburger, the availability heuristic would judge the first argument, moving from Pizza Hut to me having pizza, as better than or stronger than the second argument, starting from me going to Pizza Hut and moving to me having a hamburger, because Pizza Hut tends to bring up pizza much more readily, or it's much more available when we think of Pizza Hut than hamburgers are. And in this case, right, that seems like a really good inference to make. So the availability heuristic, like these other heuristics, is a rule of thumb that often is good in certain contexts, but can also lead to some errors, right? So, for example, here's a medical example, right? A doctor may overestimate the chance of a very bad medical condition, for example, brain tumors, if there are a few very memorable cases of those bad conditions that the doctor has encountered, maybe even just one case, right? So that could lead the doctor to think in subsequent cases or future cases that it's more likely that their patients have the really bad condition, because even though, right, their evidence doesn't actually support that that's likely, there are some very memorable cases of that very bad condition happening, and so they overestimate the probability of that because it's very available. It comes to mind very readily for them. Right? There's lots of examples of humans employing this sort of thing. So, for example, humans tend to overestimate the prevalence of violent crime or the proportion of crime that involves violent crime. The reason for that is that those violent crimes are very available to us. We think of them very readily. They're presented in the media very often. There's a lot of stories about murders and terrorism and other horrible things like that. And so they're very available to us, and we therefore use the availability heuristic and tend to overestimate their prevalence. Same thing with causes of death, right? Violent causes of death by things like terrorism or violent animal attacks and things like that. They're available to us. They're very vivid and striking events when they do occur, and they get lots of media attention. So they're easy to call to mind, and so we overestimate their prevalence if we use the availability heuristic. Medical examples, we already had the doctor case. It's worth noting that the availability heuristic may be part of an explanation for base rate neglect, which we discussed in a previous video, right? If true positives of a medical test, are more available or more salient tests than the false positives, then we may overestimate the probability of a true positive versus a false positive, which would be tied to our committing the base rate fallacy. Advertisers and marketers certainly take advantage of the availability heuristic, trying to get us to associate different products with, smiling people, happy people, having a good time, right? Even if there's not a strong evidential connection between those actual products and having a good time or being happy, once we've seen those images, we might associate, it might become very available to us to associate that particular product with whatever the marketers want us to associate it with, happiness and smiling and all such things. Okay, so we can add the availability heuristic to our list of heuristics that Kahneman and Tversky proposed we use in forming judgments about probabilities. So we had the representativeness heuristic, that we tend to estimate the probability of a particular outcome of a process according to how representative that outcome is of the process. With the anchor and adjust heuristic, if we're trying to come up with any sort of numerical estimate, including a probability estimate, we try to fix on some salient anchor and then adjust up or down a little bit from that as we see fit. And then, of course, the availability heuristic, that we try to estimate the probability event from how available the event is, how readily it comes to our mind. Okay, and like we said, these are rules of thumb. They're not necessarily always bad to use. They have their purpose. There's a reason why we're built psychologically to use these, but they lead to biases or systematic errors in certain domains. Right? Okay, now we're going to talk about final bias or systematic error that humans tend to commit, and that is overconfidence. Right? So people have varying levels of confidence in different statements, or alternatively, we could say different levels of confidence in the strength of different arguments, if you want to speak in terms of arguments. Right? As they tend to assign various epistemic probabilities to statements and inductive probabilities to arguments. Right? And we can measure an agent's confidence in a statement, or the extent to which they think an argument is inductively strong. Although, for simplicity, I'm just going to speak in terms of statements from here on. So we can measure an agent's confidence in a statement by asking her to give her epistemic probability for the statement. Right? An epistemic probability, right, here's a number between 0 and 1, with 1 representing maximal confidence. They're certain that the proposition is true, and 0 representing minimal confidence. They're practically certain that the statement is false. Right? 1/2, of course, to mean the statement is equally likely to be true or false, and so on. All right. Now we note that, right, this is exactly what we did in the forecasting project, right? I gave you a list of different statements, and I asked you for your epistemic probabilities in them, right? I asked you to give your level of confidence as measured by a number between 0 and 1 in each of those statements. Now, what properties or what features would we like a set of assignments of epistemic probabilities to have? Well, one feature you might want such a set of assignments to have is that you'd like it to be well calibrated, right? And we can say that an agent is well calibrated just in case n% of the propositions to which she assigns epistemic probability of n over 100 are true, okay? So, for example, if I say that the probability of a proposition is 0.8, that proposition should turn out to be true 80% of the time. Or in other words, right, if I assign probabilities to a bunch of different statements, and you gather together all the propositions that I assigned 0.8 to, about 80% of those propositions should turn out to be true, right? Or if you gather together all the propositions that I assigned 0.9 probability to, about 90%, 90% or 9/10 of those propositions should end up being true, right? Because in that case, right, I'm an expert, right? I actually, right, you can put some stock in what I say. When I say something has 90% probability or 0.9 probability to it, about 9 times out of 10, that proposition ends up actually being true. Right? Now, one can test how well calibrated a person is by having them offer epistemic probabilities on a wide array of propositions and examining for each probability given how many propositions assigned that probability end up being true. Right? So we can do this with our forecasting probabilities that we've given. Now, studies of this sort have shown that humans tend to be overconfident. Right? That is, when we assign a high confidence, like say 95%, we tend to be right substantially less than 95% of the time. So if you gather together all the propositions that I'm 95% confident in, a lot less than 95% of them actually end up being true. Right? And this tendency is observed across different human groups, so students, doctors, scientists, CIA analysts, all sorts of professionals. Right? So it's a very common, prevalent tendency, and it's particularly pronounced when the judgments we're making are about difficult matters, right, or matters where there's a lot of uncertainty. If the matters are very easy, like you're asking people to give a probability that 1 + 1 = 2, or that if I drop a ball, it'll fall to the ground, right? Stuff that we're very confident of, and they're very easy questions. We will be very confident, but we'll also be right. And that'll be we'll be well calibrated on such questions. But when it's an issue that involves a lot more uncertainty, right? For maybe the sort of questions that we've had in our forecasting project, forecasting future political events, or things like that, it's much more difficult to be well calibrated. Also, if there's a lot of access to a lot of information, that can also exacerbate overconfidence because we can feel like, and even if the information isn't super relevant to assessing how likely the proposition is, we can feel like we have access to a lot of information that can make us more confident than we should be. It's interesting that use of the availability heuristic may partially explain overconfidence if our predictive successes in the past are particularly memorable for us. So if why should I think I'm, should be so confident in my own judgments? Well, maybe I can look back on past cases when I made predictions, and the ones that really stand out to me, the ones that are available to me, are the ones where I was right, or I was successful. That could then lead me to overestimate my own reliability or my own ability to make forecasts or assign reasonable confidence levels to different statements. Now, surprisingly, there is one group of people that tend to not exhibit so much overconfidence and, in fact, be fairly well calibrated in their probability judgments, and that is meteorologists or weather forecasters. Right? And that might lead us to asking about why is that the case might lead us to some clues as to how we could help to avoid errors of overconfidence. Right? So if we think about weather forecasters, right, there's some nice features to their assignments of probability. Right? One, they're making repetitive judgments. They're doing this every day, over and over again. Right? So they're getting a lot of experience at doing this. Right? And equally crucially, they're getting unambiguous feedback, right? So they can see whether or not their predictions were right or wrong, right? If they predict that it's going to rain tomorrow, they can see tomorrow, whether it rains or not, right? If they predict it's going to be sunny tomorrow, they can see whether it's going to be sunny or not. If they predict it's going to be above 80 degrees, they can see tomorrow and whether it's above 80 degrees or not, right? So they're making repetitive judgments and they're getting continuous, clear feedback on whether their judgments were right or not, and that helps them to, at least over time, really improve the calibration of their probability assignments. So that's something we can think about, and we'll think about more in terms of our own forecasting next week, how we might employ some techniques to avoid overconfidence. Okay, so this brings us to the conclusion of this week's lectures on heuristics and biases. Let's recall, right, the heuristics we've gone over: representativeness, anchor and adjust, availability. These are rules of thumb that we often employ to assign probabilities to statements or to arguments. And they're often good, at least in certain domains, but can often lead to sort of silly practices or biases. Some of the biases we've discussed: the gambler's fallacy, the conjunction-disjunction fallacies, base rate neglect, confirmation bias, overconfidence. We could have discussed a whole host of others, right? But these are all systematic errors that humans are prone to commit when estimating probabilities. This then, right, the whole point of us going over all this has been, at least in part, right, to undercut the idea that we had at the end of last week after we went over the problems of induction, that maybe we don't need a scientific inductive logic and we can just base everything off of our instinctual, intuitive judgments of inductive probability. We should be very cautious about doing that, given all of the errors that humans can be prone to, right? There is some reason to try to develop a more rigorous, systematic, scientific inductive logic. And that's what we're going to try to do the week after next when we introduce probability theory. Next week, though, we're going to first try to learn some practical, informal techniques that we can use to correct for some of these biases. So next week, we'll do a survey of good forecasting practices. And then the week after that, we'll move into more formal scientific inductive logic. Please remember to complete the participation poll and let me know if you have any questions in either office hours or email. Also, the homework 3 is online and it's due by this coming Monday at midnight. All right, thanks guys.